Dr. Mondal has just joined. So, can you hear me?
Yeah, hello.
Yes.
Yeah,
Thank you. Thank you so much.
sorry. Yeah, sorry for being late. So, yeah.
That's okay. And thanks to all the participants here for waiting patiently. And I also would like to apologize, because of this delay. But now that Dr. Mondal has joined, we will soon be starting the talk. And I hope that it will be a nice and wonderful event, knowledgeable event. So before we begin, Dr. Mondal, there are a few things. I will first introduce you and I will give some introductory instructions to the audience over here. And then you can present your screen and you can start the talk. That's fine?
Yeah, please go
Yeah,
ahead.
yeah. Okay, fine. So, good evening, all of you, and the participants, and Dr. Anmondol here. I would like to welcome you all to this event organized by the IEEE Computer Society Student Branch Chapter here at IIT Kharagpur on a technical talk on the topic software defined networking for Edge AI. So to deliver this talk today, we have with us Dr. Ayan Mondal. He is a senior member of IEEE and is also an assistant professor from the Department of Computer Science and Engineering at Indian Institute of Technology, Indore. I would like to introduce Dr. Mondal to all of you before the talk begins. So, Dr. An Mondal is currently, as I said, is an assistant professor in the Department of Computer Science and Engineering at IIT Indore. He worked as a research engineer at University of Rennes in India, CNRS, IRISA. Okay, I'm not sure what those like the full form, but he worked as a research engineer at France in France, and he was also a visiting professor at the Center for Wireless Communication Network Systems at the University of Oulu in Finland in 2023. He earned his PhD degree from the Department of Computer Science and Engineering at IIT Kharagpur in 2020. He was also a visiting researcher during his tenure as PhD. He was also a visiting researcher at INRIA in Rennes, France in 2019. He completed his MS, that is Master of Science by Research, from IIT Kharagpur, India in 2015. He received the Tata Consultancy Service, that is TCS Research Fellowship, and the IEEE TCSC Outstanding PhD Dissertation Award in 2016 and 2022 respectively. Dr. Mondal has chaired many workshops at different conferences that includes flagship international conferences such as IEEE ICC, Globecom, Infocom, HPSR, that is High Performance Computing, and SEM IEEE CC Grade. He is a senior member of IEEE and is also an ACM professional member. His area of research includes next generation networking, services and technologies, research group, and it also includes algorithm design for intelligent edge cloud, next generation networks, and the Internet of Things, that is IoT. So before the talk begins, a few general instructions to all the participants present here. So I would like to request you to please keep yourself muted during the talk, and please wait till the end of the talk to ask any questions. There will be a separate Q&A session at the end. During the talk, an attendance sheet will be distributed in the form of a Google form. Please note your attendance over there. You may type any query or issue you're facing in the meanwhile in the chat box, and we will try to resolve it. And at the end, we will be taking a group screenshot of the event. So at that time, if possible, please turn on your camera when asked to, so that we can take the group screenshot. So with this, I would like to hand over the session to you, Dr. Mondal. You may present your screen and you can start the talk.
Yeah, thank you, Gunther, for your generous introduction to me. So, yeah, so maybe I'll share my screen and yeah, so please confirm if it is visible.
Yes, yes. So it is visible.
Yeah. Okay, so please feel free to ask question and and if you have some suggestions or you want to discuss anything, please go ahead with that. So I'll be happy to interact and maybe like answer your queries more than the presentation, because this is something is currently people are working on, and this is one of the promising areas that you can think of. Yeah. So the topic I have chosen for today's talk is software defined network for Edge AI. So most of you like might be familiar with SDN and Edge as well as AI. So these are three different verticals you can think of from a research point of view. And today through this talk, I'll try to uh, make you through the ideas that have developed in the past and what people are doing and how things are working and why it is like for age AI, why SDN is important and why all of a sudden age AI is all of a sudden is important. So yeah, so please bear with me. So that's it. Yeah, so this is the outline, but here's thought of what I've planned for. I'll talk about some introduction, then I'll try to some give you some basic about software defined networking if you are not familiar with. Then we'll talk about age AI and what we are looking into, some use cases that are there or people are working on. Then I'll try to go through the performance metrics that we look into whenever we are talking about using age in terms of any particular application area, and there will be some future direction that we are working. And I hope that some of you might find the topics to be interesting, and you guys also start working on those domains. So that's how the research community goes. Yeah, so to talk about the software defined edge AI, so yeah, so what we are trying to look into, as I have talked about, so these are mainly three verticals we are looking into. So one is software defined networking, one is edge or edge networks, okay, and we have edge AI, sorry, AI. So what we are trying to do over here, so we are mostly doing it. So there are two concepts that are there, okay, but we'll be focusing through this talk. We'll be focusing on one particular topic. So there is AI for networks, where you can use the AI techniques to optimize the performance of a networking, and there can be network for AI. So mostly what we are doing over in this talk, or what we'll be discussing, is network for AI. That means we are trying to ensure that the network configuration is what should be the network configuration, how we can work on it to make sure that the AI or artificial intelligence algorithm that you are running would be much more efficient and would give you a age, or not that age, but it would give you a perspective to the data or perspective to the coming networks that you are looking at. So what currently it is getting done, so let us talk about that, then we will talk about how SDN and age is can be clubbed into this. So why, how currently you are doing it, maybe most some of you have been working on AI. So what you do is basically you have a GPU server or TPU or a DGX where you have multiple cores and all. So you try to download some data or try to generate some data. You run your AI algorithm. So there has to be some training, testing, and validation phase. You start working on training that data, and once the validation is done, either you can work on use that particular trained model to perform some of the tasks, or what you can do is also we can through cross like while deployment also you can keep on learning. So that's how we do it, but mostly we are uh, rely on more mostly how should I say it, that um, high computation or computation intensive structure infrastructure that we have. Okay. So that's how the cloud computing was very much popular in last, I would say, decade, and people have started working, and few of the companies on most of the companies that provide these cloud-based services are mostly dealing with AI or AI process services, mostly use the cloud infrastructure to process their data. But what is all of a sudden why age is important? Okay, so the point is, if you think about, so I mostly work on IoT, so I will give you a perspective from IoT, but yeah, of course, from your domain also you can think about different perspective. So from an IoT or Internet of Things perspective, so you can think of number of devices we are carrying. So for just for example, like I mostly carry 3 4 devices with me all the time. So be it a smartwatch, be it a phone, be it a laptop, or be some smart gadgets that are there. Okay. And through survey, it has been known that within an area of, let's say, 10 kilometers or 10 kilometers, so people, mostly if you are considering a urban population, so mostly you can consider around 1.5 to 2 lakhs of devices within an area of that. So not just personal devices, but the devices that are there installed on the roadside or installed on like the smart now we have smart banner and all, where you can change the banner from the remote location and all. So all of these devices are connected to, let's say, some cloud server, and of course you can use like manual intervention for more controlling these devices, but mostly from a autonomous point of view, what we use is, we think of that AI should be able to capable of handling these devices. Okay. So now the problem comes into the network infrastructure that we are having. So given the current network scenario, so we have a bottleneck at the core of the network. So if you think of the devices that you are connected with, so all of you might have experienced this one. Okay, so all of you might have started using your mobile maybe in 2G or 3G. So there the speed used to be like very less in terms of kbps, or like 10 to 15 kbps, something like that. Now there is LTE and 4G came, and the experience become little better than 2G and 3G. Okay, but with the availability of 5G, you can see that the data rate that you are getting is not that significant. From 3G to 4G, that was a significant jump, but from 4G to 5G, that is not a significant jump. Okay. So this is not just due to the network capacity that we are having. So there can be multiple factors. I'm not going into that. Okay, but there can be the slicing and all other network, how you design your network, how you manage your network. So those things also comes into picture. But one of the important aspect is the amount of data it is generating, and the number of devices that are connected with an internet. So now, given this current scenario, it is hard to give or take your data to the cloud, all the data to the cloud, and process it, and then again actuate something. It is, I would say that it is infeasible, impossible, but it is down the line. Maybe we can think of growth in 10 years or 15 years, it would be close to impossible. Okay. And also there is a possible problem of, you might know that climate change. Okay. So what is happening that these data centers are mostly like, uh, generating huge amount of heat through the data centers, and you know that some of the data centers are placed under the ocean, and that is basically increasing the temperature of the ocean. So that's how things are getting like multifolded, and it is a problem in that sense. So that's how the age people have motivated them to work on age. So now to talk about age, so we'll talk about. Let me brief it maybe at this point, and then maybe we'll also take it forward and try to discuss that as well in the consecutive slides. So in age, what we are looking into is we are trying to bring the processing unit closer to the user. So in cloud, we used to call it a remote server, or it has to be somewhere there physically, but you don't need to know the location of the server and all these things. But in edge, what we are saying that it has to be close to the user. But of course, we cannot expect the computation capacity of a cloud at the edge. So what we are looking into is basically we are agreeing that the edge devices are not computational intensive. So we have some computation limitation, but what we have, what we can take advantage of is basically the number of devices we can increase. I won't say exponentially, but it can be increased to a greater extent. Okay. So that's how these edge networks is taking a promising steps. Okay, and what we are looking into instead of, so in cloud computing mostly what we are having is like there also it is distributed, but it is distributed within a certain data centers that are there. Okay, so mostly the distribution is getting confined, or from a graph point of view you can think of the cardinality of the data
Hello,
centers
sir.
or the, yeah.
Yes, your slides are not changing. Please continue.
Yeah, yeah. Sorry, I didn't change my slide, so I'll come to it. Okay, so sorry, I just trying to motivate you how we are talking
Oh,
about
okay, okay.
age,
Yes,
then we'll
okay,
talk about,
okay.
yeah.
Okay,
So
sir. Thank you.
yeah, so what we are looking into, like at this point of time is to enhance the computation power from a using distributed computing platform. Okay, so okay, so earlier parallel computing was there. Okay, so you do have multi-threading was there. So there are different concepts are there. Like you have these uh, migration of data resources. You have Docker, you have Kubernetes, you have like AWS, and so many things were there, which were mostly there for the cloud. Okay? So now, if you know, if you are using or working on edge, then you know that AWS and Kubernetes, they are trying to develop their software platform for the edge so that it can be easily they can easily integrate these to the need of the current scenario. Okay, so that's where the SDN also is a promising architecture that you can think of to enable these edge platform. Okay, which would be used for AI performing AI operations. Okay, and in this topic, we will be looking into how SDN can optimize the infrastructure to support these AI applications. Okay, so edge, so now, why I was talking about the edge. So this is one real-time processing that is in needed. Okay, so cloud earlier it used to be a real-time processing, but considering the amount of data it is generating and the location of the, so now you can think of that I'll talk about India. So now India is mostly digitally connected. Okay, so due to the movement of digital India, so in remote places also now we can find that there is at least 3G connection is there. Okay, so where the 3G connection is not there, BSNL now took an initiative to make it accessible to the like remote, very remote areas by end of 2025. So that's the aim of the government. Okay? So we taking appreciation of that, what we are looking into, that those who are having very limited access to the internet, okay, and maybe having a low connection, so they should also get their data processed in real time. Okay, so if you think about in the remote areas now, these remote healthcare operations, healthcare opportunities are there. So there is these autonomous vehicles are happening to be very much attractive in India. So I don't know all of you have seen it or not. So there was some guy who took his Mahindra car and make it a autonomous car, which was kind of a motivation from making India. And like the owner or CEO of Mahindra has taken initiative, or not that initiative, but have appreciated him over the Twitter and all those things. Okay, so this is a global recognition that is happening, and this can only happen if we have the real-time processing capacities. Okay, so now the applications we are talking about, would be talking about in this particular talk would be autonomous vehicles, smart cities, industrial IoT, and so on. Okay. So the challenges we are looking into is high latency, as I was talking about. If you look into the cloud aspect, so the main challenge is that it faces is limited bandwidth, and which incurs to the highest high latency, because these two are very much related. Okay, and scalability is also an issue in traditional networks. So this is not in terms of cloud, but if you look into the traditional networks, what happens that traditional network means, what I'm saying, that you have traditional switches and routers where you have to decide the routing tuple by using the neighborhood exploration and all other possibilities or all other algorithms that are there. So the scalability is an issue because you need to put much more money into it in order to make it scalable. Okay? Because these devices are like huge, high in cost. Okay, so that is why it is not scalable, and that's why this SDN will take. SDN has an advantage over the traditional network. Okay? So what the edge AI or what the edge is trying to help in, so instead of, so you can think of the importance of edge AI than using cloud AI. Okay, so that basically reduces the latency, and as the computational devices are closer to you, the bandwidth is much more like you can use the available bandwidth in very much efficient way. Okay, so if you know there is a like famous network problem, which is like the bandwidth allocation problem, where you can allocate. So if you have a certain cell, so you cannot allocate the same bandwidth allocated to that particular cell to the nearby areas, because there would be then interference would be there. Okay, so now considering that, okay, so if you can reuse your bandwidth, and the devices that are the edge devices that you are connected to is working on that particular frequency band and it is closer to you, so the data communication gets faster. It can process the data. Like if you have multiple edge devices, it can process the data uh, as per the need you have. Okay, so and it can send the process data to you. Okay, so just a disclaimer is that we are not saying that we are trying to replace the cloud infrastructure by using edge, but what we are saying that instead of sending all the data to the cloud, what we can do is process at the edge. Certain amount of data can be processed on the edge, and then you try, if needed, you take a help of cloud. Okay. So by doing that, what we are trying to do is we are trying to use the available bandwidth very much efficiently. We are reducing the latency by not sending all the data to the cloud, but only the uh, information that is needed or that is very much crucial or that needs a high computation capacity. So we are only sending those data to the cloud, and whichever can be processed on a lower computation platform, we are on that platform itself. Okay. So just to take you an example, so let's say that you are trying to monitor a fire, like fire situation, if there is any fire situation. So earlier with cloud computing, what we used to do, we used to send the temperature data to the cloud and try to understand if like what is the surrounding temperature, what is the number of people that are there, what is the body temperature that is happening, and how much is heat is there. Then you try to decide if there is any peak in temperature, if there is any fire or not. Okay. So in order to process this data on the cloud, you need to send a continuous data to the cloud and it gets processed. But think about the application, it is not having any multimedia data and it doesn't require a high computation capacity. So that those are the applications we are trying to look into to process on the edge. Okay. So this is just for one example. So take the example of healthcare. Okay. So let's say that uh, mostly what happens currently, I don't know if you if you follow the world news or not. So recently in China, so there was a remote operation that happened. Okay, so then where they have used their 5G communication and operated the patient from a remote location. Okay. So that can only be feasible. Okay, so with the help of a both edge and cloud, because what is happening that the doctor is operating on the patient. Of course, for that he need help of cloud. Okay, because the image has to be processed, it has to be transmitted to the remote location and all. But the patient doctor who is operating that on that particular patient, okay, doesn't require to get the basic uh, or doesn't need to know the basic values that are there, like what is his heart rate, what is pulse rate, and all other things, because there would be some paramedic would be there to take care of that. Okay, so now what we need, but they might not be very much adequated about those parameters. So what you can do is, instead of sending the continuous data to the remote location, and because that will also use some of the bandwidth that you are using for remote operations. Okay, so instead of availing that bandwidth, what you can do, you can use some edge devices to process that data on the edge, and some multimedia data or some video footage can be transmitted to the cloud to process on that end, and then we can transmit whatever information is needed to different location. Okay, so what we are saying that for to a remote location there might be a need of different information which can be processed on the cloud. There might be a different need for the local community or local vicinity, where we can use the edge infrastructure to process the data. So basically they have to go hand in hand, so that that's why this edge cloud continuum comes into picture. Okay, so this is just to motivate you about, we are not discarding the cloud, but we are trying to like come in between the cloud and the user, and take some advantage of low processing unit which can be scalable on a like higher rate than the traditional networks. Okay, so now let us talk about SDN a little bit, because I haven't talked about it. So how SDN is one of the promising in case of edge. Okay, so basically what SDN does, separates the entire network plane into two planes. Okay, so think about this, that uh, your body needs to perform any task. So first, what you do, you first sense the whatever a job you need to do. Let's say that I want to move my phone from one place to another place. So first, I have to look at the phone, because if I don't look at the phone, then I don't know where the phone is placed. So first job is of my eye to look at the phone, then my hand will coordinate with the eye and pick up the phone, and it will place it somewhere. Okay, so this is the work of a like limb and all other body parts. Okay, but in case of networking, in case of traditional networking, what happens that the you on your own, like your hand has a separate brain, your eye has a separate brain, and your limbs has a separate brain, and that's how they try to coordinate among themselves. Okay, that's where ASEAN comes into picture and says that, okay, instead of having multiple brains into the network, what you can do is you can have a centralized control which can be felicited to connect with the limbs and all other devices that are there, and those devices just follow the instruction that is sent by the brain of the network. Okay, so that's how the network is getting divided into two planes. One we call to be a control plane, one we call it to be a data plane. So control plane is the brain of the network, and data plane is the limbs and body parts of the network. Okay. So by doing that, what we achieve is we achieve a centralized control. Okay. Centralized control over the network. So it gives you a bigger perspective, and it gives you any fault that is there, you can quickly resolve those issues, and you don't need to rely on ICMP messages like traditional network. It can be programmable, so that is one feature that has been not there in traditional networking, but now you can program your devices. So there are different uh, programming languages that are there for the programming. So mostly in case of software-defined networks, we use P4 languages, but there are other languages that supports these now. They support Java, they support C++ as well as Python. So flexibility is also one of the key features. Okay, so flexibility in terms of scalability. Okay, so as this is a softwareized platform, in with the need of the network, you can easily scale the function, network function that are they are needed for the time. You can easily install it through a particular command, any particular like command from the control center, and that is, you don't need to. So earlier in traditional network, any function that needs to be installed in particular switch or any particular network devices, some you, network manager has to go, or network modifier, or some person has to go in the device, has to take control over the console and has to update. Now we can do it remotely through the controller, and it becomes much more flexible, and that's how the scalability helps into picture. So how this SDN, what it is doing, it basically simplifies the network management and enhances the performance. So how it is enhancing the performance? By giving a centralized control, because now you know what is happening in any part of the network. Okay? And it can be done through the centralized controller itself. So if you know about the Kubernetes and the Docker architecture, so there is to be like, it also follows the similar architecture of SDN. I won't say that it is following the SDN, but it will follow the similar architecture. That is, there is a concept of master node and there is a concept of worker nodes. Okay, so master node is basically capable of implementing or instructing any information or any particular instruction to the worker nodes, and whatever worker nodes are doing and what is the status of the worker nodes can be easily known to the network manager or the manager of these distributed platform through the master nodes. Okay. So that's how this SDN, and we are saying that Docker can help you. So basically, in order to implement the edge networks, we are using the Kubernetes and edge, which have a prevalent architecture, centralized architecture, and that's why SDN is also capable of getting integrated into edge without any much more complexity. Okay. Yeah. So why edge? What is edge AI? So edge AI, as I've talked about, so AI processing is getting down at the edge networks, and which is closer to the data sources instead of having it to the cloud. So the key features we are looking into is real-time processing. Of course, we are saying, so given a constant that these are having limited computational capacity, so real-time processing of a lower computation that we need to always address or always think of whenever we are implementing or we are trying to design some module or some network architecture for the edge. Okay? So of course it reduces the latency because the data doesn't need to go to a remote location. It travels a shorter duration, and also the bandwidth availability is much more higher because you are not intervening with a core of the network, and there is no like bottleneck situation may happen, but it is less likely to happen in over the edge. So faster decision might come, okay, because you are getting the data much more earlier, but it is, so it reduces latency in terms of propagation delay and transmission delay, but it increases latency for the edge. It increases latency in terms of computation. Okay, so now whenever you are thinking of any application to be solved, you first need to look into what is the total overall latency of the system or overall latency of the service, including the transmission, propagation, as well as computation. Now, if your computation or latency is much higher, then the transmission latency, of course, you should go for cloud, but has to be a trade-off between these two. Okay. Decentralization is getting done over the edge because you have a distributed network and it is not needed. So those, though we are talking about SDN as to be a centralized platform where you have these controller, but it can be also distributed to say, because there can be of multiple layer of these controllers. Okay, so multiple tier of these controllers. So that means some of the network devices, be it switch or router, L2 switch or L3 switches are connected to certain controller. There might be different networks of different controllers. Now these controllers can communicate among themselves. So there is a concept of APIs. Okay, so application interfaces through each API. So there is a concept of APIs in case of SDN. So as we are talking about this network control plane and the data plane, so mostly they communicate through the southbound APIs, and there is a concept of northbound API which talks with the control plane with the application plane. Okay, so there are three planes in SDN. So just let me see. Yeah, so there you have the components: control plane, data plane, and the application plane. So control plane and data plane communicates among themselves using southbound API, and data plane and application plane communicates among themselves using northbound API. But as I was talking about, it is a decentralized system, so you can have multiple controllers and they can communicate among themselves through eastbound API. And there is also a concept of westbound API which can be used. So it's not that we are saying that using SDN you just discard your traditional network, but the SDN is also capable of communicating your traditional network devices through these eastbound APIs. But of course, these devices or these SDN enabled L2 and LC switches are not communicating with the L2 and LC switches directly in the traditional network, but through the controller. So the benefits we are looking into through Edge AI is improved response time, better privacy. Privacy is higher. Of course, you can understand that your data is not. So there was a case of data privacy in case of Facebook. If you, I don't know if you have followed it or not, because the data used to from India, it used to go to, I think, somewhere in Europe, and there was some data breaches happened, and then the government instructed that the Meta has to have their data was somewhere in India if they're planning to use the Indian data set or use the Indian data set, then they had a tie-up with Reliance, and they now they have certain number of servers in India. So it always, so given that scenario, so age is not going beyond a certain point. So it's much closer to you. So the privacy that you can it can ensure that a higher privacy in that sense, because the security or the protocols that you use for clouds that also can be used for these edge devices, but of course it cannot be computation intensive, but of course you can have a better privacy. And also with the use of this SDN there, we can also have a better improved uh, security as well. Okay, so so just bear with me. So there are two concepts: privacy and security in this, and reduce bandwidth usage because you are not clogging the core of the network. So that's another advantage that you have. So how we are synergizing? So that I've already talked about. So SDN provides a network flexibility that is needed for these AI. Okay, and we are so there is also concept of network virtual functions as well as virtual network functions. So the both of them can be part of SDN as well as they are also part of 5G networks. But this SDN and 5G is somehow different. But yeah, of course, so both of them have the network, ensure the network flexibility. And also dynamic resource allocation can be easily done in case of SDN because There is a concept in ACI, instead of each packets, you try to deal with the flows. Okay, so you can think of that for each flow there can be millions of packets. So instead of looking into each packets, if you look into the flows, the number of flows that is going through the network is much lesser in number than the number of packets that are there in the network. So then, in that sense, ACN is also giving you a better managerial or optimization capacity over the network, and you can always change the network routing or any bandwidth allocated bandwidth, and in many more parameters dynamically through software platforms without affecting the other performance that is happening. Okay, so that's how this dynamic resource allocation, in case so in HDN, this dynamic resource allocation is already there, so it can also help in this real-time AI workload balancing. Optimized routing, as I was talking about, you can choose at any given point of time, you can change your path, you can migrate your services as needed whenever, and through the some commits from the controller itself, so you don't need to go and change the path. Okay, or the switches or the devices do not need to take any decision on the behalf of the network, so the network is capable of taking their own decision to manage the whole network. Scalability is also an important issue because like earlier without ACN it was not feasible to scale the functions or network function that is needed with the fraction of a second. Earlier it was not there, but with the help of ACN it is now there. So in case of ACN architecture, what we are looking into, there are three planes mostly we talk about that. We don't talk about the eastbound and westbound API. But the control plane, which is a centralized intelligence platform, or which is the brain of the network, data planes which executes whatever the instruction that is given by the data planes, and application plane is basically the application that is running over the network. Now, in HDN also you can have the flexibility of running or giving the application to have access to the controller, and they can send instruction to the controller from the application itself and make their requirements available to the controller, and that's how the service quality of service or quality of experience is much better in case of using ACN than using the traditional networks. Yeah, so I won't take much time, but I'll try to contribute. So flow operation is controller change so how this flow operation is happening. So whenever there is some, so as I have talked about, so in case of ACN, so we are looking into flows. Okay, so when there is a new flow coming into any particular switch and it is not able to understand or not able to recognize that particular switch, and what it does, it basically sends a packet similar to the ICMP to the controller which have the metadata of the packet, okay, or the metadata of the flow, mentioning the source and the destination or different other parameters or flags. Based on that, the controller decides which paths to be chosen. Either it has to give that flow a chance to transmit the data or not. It also can update the flow table if needed, and installs the data plane to handle the traffic based on whatever the performance metrics they are looking in case of Edge AI architecture, we are looking into different. So as I was talking about, so in Edge AI, we are not just looking into the edge, but we are trying to help the cloud and make the system much more better. Okay, so edge devices is nothing but the devices that are collecting or close to or with the user itself. So it might be sensor, it might be IoT devices, or it might be gateways that are generating or collecting data or transmitting the data to some remote location. Now there is a concept of edge server, which is a local processing unit. Okay, so edge server is not having the same computation capacity as cloud, but it is much closer to the user than the cloud. Now this with Of course, you know the cloud is a centralized processing unit and it can perform complex tasks and it has a higher storage unit. Okay. So if you think about that, like it's kind of this edge server is kind of in between the edge devices and the cloud. So the operational benefit, as we have mentioned earlier, that the data is processed locally on the edge, so you have a higher privacy. Only necessary data is getting sent to the cloud for further analysis, and that is not all the data we are sending. But also there might be one another possibility is that you can. So data cleaning is one of the crucial tasks whenever you are performing AI techniques. So data cleaning also can be done on the edge because it doesn't require a higher computation. But as this is like continuous data is getting generated, so you can just check that if the data is a valid information or invalid information and clean. You can clean the data using edge very much efficiently and process some of the data at the edge. So network configuration. So SDN enables the dynamic and programmable network configuration, which can adjust the need of edge AI, as we have mentioned about. Okay. And how SDN is helping edge is basically doing the allocating the bandwidth and the processing power. So think about that. You have multiple edge devices and you need to process a particular data. So now you can have the process the data on a single server or single edge server, or you can distribute it on multiple edge servers. But if you're doing it multiple edge servers, then there has to be some synchronization has to be done in between that. Okay. And the allocation of bandwidth also has to happen accordingly. So SDN can help in that, which will enable to use the edge platform for the AI in a better way. Okay. And network slicing is also an important aspect where ECN is capable of, and you can look into the different requirement of your network, and you can do the slicing through your softwareized functions very efficiently without earlier it used to be done for each of the devices separately. Now you can design a function and that can be defined over a path, and the slicing will be done accordingly. Traffic engineering is also much more efficient than traditional network using SDN. So you can reduce the latency and you can choose the optimal path in case of there is a failure or there is a another requirement, or let's say that we have different priority of data getting sent over the network. So if some higher priority data is getting or just came in and it needs to get some like it needs to be sent the data through the network in a priority fashion, that ASEAN can handle the priority based flows very efficiently without any hassle. So the benefits for ASEAN and Edge AI is basically reduce latency, improve resource utilization in terms of bandwidth as well as computation, and as security. So ASEAN allows the centralized security management across the network. So that is one issue, as well as you have the privacy due to your performing the processing the data over the edge. Okay, so now let us look into different use cases that are there. So in case of autonomous vehicle, what is happening that so if you have looked into the functionalities of autonomous vehicles, what it does. So there are two different aspects. One is the movement of the vehicle, and so there has to be some sensors has to be there on the device itself so that it can choose what are the actions has to be done within the car itself. Okay. And there has to be they have need to interact with the outer world as well. Okay. So in order to process the data, you can have the edge server on the vehicle itself to process the local data. Okay, so it might be the pressure of the trial, or it might be the fuel capacity or the charging level that you are having. So you know you won't be willing to disclose this information to the outer world, because this is very much your personal details. And if you disclose this information to the outer world, so, and somebody have access to this information, they can easily identify what is your daily life or daily life structure, and they can take some malicious decision based on that. So there has to be some safety has to be there in order of privacy and security. So in case of autonomous vehicle, what you can do, we can have these edge devices to perform some AI operations over in the within the vehicles on the premise itself. And you can also have the cloud to identify which paths to be chosen. Okay, let's say that Tesla, what they are doing is they are having Tesla cloud servers, and they are doing it remotely, but with the help of edge, some processing can be done on the edge itself, and that will enable them to take a faster decision. So you might have seen that these autonomous vehicles are not like crash proof, so there are multiple incidents of accidents that happen because of like intermittent connectivity. So that might be one issue, or the decision that uh, would have been taken with a shorter duration, it took some longer time. Okay, so now let's say that now if you follow these current vehicles that are coming that came into 2023 or 2024, there is a concept of ADAS, or now advanced ADAS and all other things. So mostly these are the things is getting done over the edge. So you have your computational device on the vehicle itself, and it is trying to decide it needs to do. Okay, so if you have adaptive cruise, it senses what are the vehicles that are there in front of you, and it tries to predict what should the speed and how they has to be controlled and all other things. Okay, so through this example, what we can understand, real-time decision making is much more flexible with this edge platform, as well as SDN. Of course, it is there so that you can decide which are the data has to be processed on the edge, and which of the data has to be or which of the flows has to be processed on the edge, and which of the flows has to go to the cloud. That you can do in using SDN. Enhanced navigation can be ensured, as well as safety enhancement. So safety in terms of your vehicle safety, your personal safety, as well as your data safety. Okay. So uh, the current work that we need to do is with the help of these enhancement of these VLSI platforms and all other combination capacity getting increased. So now these edge devices are capable of processing high volume of data, and maybe to some extent some high complex data as well. So how we can use these autonomous or each platform to make these vehicles more autonomous without having any intervention from the cloud. So and uh, where we can take the advantage of this low latency and reliable connectivity in the scenario. Okay. Smart cities is one of the application where you can use the same kind of benefit you get, that is optimized resource usage, um, latency critical applications are getting served, as well as enhanced citizen experience. So that is the quality of experience I was talking about. Okay. So in case of smart cities, we can look into a different perspective. You can look into the infrastructure, you can look into the traffic, uh, vehicle traffic, you can look into the public sector, you can look into the banking finance, how it is getting done. So now there is a concept of these UPIs are getting happening, like mostly India become digital, and UPI is one of the promising technology that came from India and to the world. Okay, so now with the help of this using UPI, so it might happen that you are not able to. So now we also get these errors that your banking server is not working. Okay, but do we need always the banking server, or we can use some blockchain technologies to enable these AI techniques, as well as with the integration of blockchain, can we do it without intervention of the cloud infrastructure and do it on the edge, and whenever the connectivity is available or the remote server is available, that data gets processed and that data gets updated in the cloud itself. So these are the different possibilities that we can look into, and of course, I welcome all of you to explore. There are multiple problems that are there which can be solved using edge, and currently which are getting solved with the cloud, but it can be solved using edge itself. So now industrial IoT is also another application that you can look into. So now there is a concept of earlier till 2023 it was a concept of industry 4.0 where people are looking into make the system more smarter and trying to connect these IoT devices that are used for industry to connect with the internet, and so that the devices that are there becomes much more smart, and you can take much more the decision, more flexibility to be there, and the managerial capacity to be on the higher side. Okay. But with the help, so now there is a movement going on for industry 5.0. So in case of Industry 5.0, what we are looking into is use these Edge AI platforms to take some predictive maintenance. So in case instead of having it a reactive maintenance, we are looking into the predictive maintenance process optimization used to happen. As well as safety is one of the important aspects. So safety of the users. A user means like the workers that are there in the industry. We are not, so in industry 5.0 we are mostly looking into sustainability, resiliency, and the involvement of the safety of the users or safety of the workers. So these are the different aspects we are looking into where age can be, or age AI can be one of the promising techniques. And of course you can try to explore how we can use these ACA technologies kind of to be useful in that context. So now we have talked about two aspects in case of SDN and Edge AI. So Edge AI ensures the data privacy, and SDN ensures the network security, and ACN ensures the network security is through centralized management, and it can use, as you are having a centralized control over the network, you can detect or update your network about the threads that is happening in any part of the network very quickly in throughout the network within a fraction of a second. Okay, and also the data processing is happening locally, so the privacy is higher, and also ACN can enforce some encryption protocol across the network. Okay, so ACN is capable of that as well. So ACN, so these are the facilities or security or privacy issues which are provided by ACN can also be used for cloud. Okay, but we are looking into how it can help for the edge itself. So now how we are planning, or how the research community is evaluating the performance of the edge is through latency. How much latency we are we are capable of improving. So latency in terms of propagation, transmission, as well as computation. So we have to take end-to-end latency, okay, of a service. Throughput, how much data we are processing in a specific time frame. So this throughput is not just age, and if you are using it for only age, then you can look into the throughput of the age, but you can also look into the throughput of the whole network in terms of sorry, edge cloud continuum. That is what is the throughput you are getting over the edge as well as cloud. So and also resource utilization is one of the promising thing, and you can check how, if you don't use SDN over the edge, what is the resource utilization, and if it is edge, what is the resource utilization, and that's how we try to evaluate the performance. Fault tolerance is one of the inherent network metric that we use in order to check the performance of any kind of network. It might be edge, cloud, or traditional network. It might be like any kind of network that you can think of. Yeah, so scalability and flexibility. So HDM makes it more scalable, and with the use of edge, it makes it more flexible, and due to this programming infrastructure as well as having the centralized control and a distributed network. Okay. And we can do it on a larger scale using HDM within a shorter time. So that is how it is flexible. So now there are different challenges that are there or limitations that are there. Okay, so one challenge is the interoperability. So this is mostly that is there in any of the network. Okay, so or any of the devices. So if we talk about IoT devices, like these devices comes from different vendors and they have their different protocols. And if you know the protocols that are there for the IoT devices, to be specific, uh, these protocols are not interoperable, operable. So what you need to do, you can look into designing different hypervisor or intermediator plane to make it interoperable, as well as integration of complex networks that is very much so. What we are trying to do is we are trying to add three verticals into it. So integration of these in different scenarios is much more complex than we talk about. Okay. Security risk are there. Okay. Though it is a centralized platform, but centralized platform always have their a single caller failure possibility is there. So there also some work is going on. Okay. So there is also potential bottleneck because of the edge devices are closer to the user, and it has the bandwidth allocated to each of the devices is much lesser. So there is a hardware limitation is there. So how we can overcome that and how we can use considering that hardware constant, and how you plan to manage the network. So that is also one thing to look into. Dependency on the infrastructure, as I was talking about. So though we are saying that you can use this programmability to scale your network, but this programmable like different vendor use these before they are before these predefined functions are different. Okay, for infrastructure it is different, for different vendors it is different. So how do you tackle that, and how do you make sure that their dependency is ensured? Okay, so that is also one thing you can look into. Okay, so there is also a challenge. So that is not related to age, to be specific. One is addressing challenges. So with the increase of these in the number of devices, we are losing out the flexibility to allocate these IPs to the different multiple devices, and uh, it is getting considered that within down the line by 2050 we would be exhausting all the possible IPs that are there, and we should think about different standardization for the edge. Maybe we can use these IPs for the cloud infrastructure where we have limited number of devices, but for edge, if we can have some addressing techniques, okay, which can be clubbed with the IP infrastructure or IPv4 or IPv6. So that is one thing people are working on, and of course, you can also look into that. You can also look into the security measures, and in that context, and all those, like there is low limitation or no like way that you can define what can be done, and there is the possibilities are endless. So now where we are currently working, is basically in our group. We are currently working on AI-driven SDN. So what we are trying to do is we are trying to use AI. So earlier throughout the talk, I have talked about network for AI, but the future direction is not just network for AI, but AI for network as well. How you can use these AI techniques to optimize your network performance as well as like it's AI for network for AI. So kind of AI on the both end and network comes in between. So you are trying to optimize the performance of the network using AI for the AI. Okay, so that's what we are looking into, and in our group as well as there are different other groups throughout the world, and I know that Bhumteo and Professor Michel who was also working towards this direction, and also we are working towards the 6G network. So in case of 6G, what we are looking into is to make the network more flexible and capable of performing very much autonomous or self-filling properties has to be there. So there has to be SDN, and AGI can be one of the promising technologies that can be used. So it will, we won't discard the 5G networks, but it will just come as a bridge in between 6G and 5G, and we'll use the 5G network. You can use the 5G network and use SDN and AGI to realize some of the properties that has been proposed for 6G network. Edge native AI models, so that is like AI models getting designed for the edge. So this federated learning to be one of them, one of the AI models that has been developed for the edge native platform. Of course, so in terms of HDN, you have the flexibility to enhance programmability, and you can design the program or you can design different AI models to define the program or based on the requirement. So that is dynamic programming using AI. So that is one aspect that you can look into. Autonomous networking, so networking that is self-filling, self-manageable and self-optimizable. So that is also one aspect. It is mostly open. I know that there are few people working on this particular area, and yeah, so these are different potential areas, and that's how we are looking into HDN and HAI to come hand in hand and uh, make the network a better platform. Sorry. So please, if you have any question.
Yeah. So thank you very much, Dr. Mondal, for this wonderful talk. The session is now open to Q&A, question and answers. So among the audience, if any one of you have any question, you may unmute yourself and ask.
Yeah, so there are a few questions in the chat box. I'll go through that and try
Yes,
to
yes.
answer that. Using AI in ASEAN, will the ASEAN architecture changes? No, we are not changing the ASEAN architecture. We are not saying that. So ASEAN basically says you that you are trying to divide your network into two planes, control plane and the data plane. And like as I was talking about, this control plane is considered to be the uh, brain of the network. So what we are expecting that we can have these AI models running over the controller. So of course the controller might need to change, because now the controller that we are consider for the SDN is not that computationally extensive or computationally capable of doing that. But you can think of that the controller would be much more capable of running the AI, and that's how it is. Uh, we are trying to advance the SDN architecture. We are not modifying the architecture to be precise. So hopefully answered your question. So is it possible to coincide cloud server, edge server, and yeah, so there is coincide means like I'm not sure if you're talking about edge to be within the cloud. or it is working hand in hand. So just to give you a short answer, that we are considering the edge cloud continuum platform. So that means we are talking about the continuity between the edge and the cloud, where some of the data would be processed on the edge, and if you need some data to be processed on the cloud, you can take help of the cloud. And we are not looking into the vice versa, because we are not saying that whatever the process are running over the cloud, you need to give it to the edge to process that data. Because if some data is processing or generated at the cloud, it is not uh, makes much more sense to send it to the edge and process it over the edge. But of course, if you have the generated data in the cloud, or you are generating in the cloud itself the data, it would be better if you process it at the cloud end itself. But if you are generating the data on your end, on your personal devices, or the sensors, or the device IoT devices, or the gateways that are there, it's better to use edge as much as possible. Okay, but of course there would be a limitation on that as well. Which is more data secure, edge or cloud? Okay, so yeah, so as I was mentioning about that, security comes from mostly the SDN architecture. So most of the protocols that is capable of securing the cloud, it can also be used for edge. Okay, so in with the aspect of security, it's both edge and cloud, both are secure. But I would say that cloud is more secure, because it depends on the security, mostly depends on what is the complexity of your security algorithms. Okay, so being a if your computation algorithms are what I should say, that it's not computation intensive, or encryption is not um, much more strong, then it is more likely to break. Okay, so in that sense, and also edge being a distributed in that sense, cloud is much more secure. But edge being a distributed entity, so it is more likely you have a better security, because you cannot affect all the devices at the same time. So that's how it's basically a trade-off. Okay, so what kind of security you are trying to ensure, or what kind of attack you are trying to looking into. So in that sense, in some of the aspect, edge is more secure than the cloud, or they are mostly similarly secure. Okay, so yeah, so hopefully answered. So now there is another question. In 5G architecture, how SDN can has been integrated, and which controller are used by the user? Okay, so mostly like the SDN controllers are getting used. So mostly, what I of know of is, I think Google uses SDN to manage their cloud servers. Okay, but I'm not sure about the controller. So I think either it is Onos or Ruby. Okay. For AWS, they have their separate controller, which is not accessible, or which is not available publicly. And so, to answer to your first question, that how SDN has been integrated in the industries like Airtel and Jio. So most of them are not using SDN like uh, very often. Okay, so SDN mostly these data servers are using SDN currently, and for IoT infrastructure, like we have very much limited functionalities of SDN, so it is not explored fully. So what we are mostly using is some network function which can be installed virtually in different other platforms, and that's how people are implementing, but there is much more to this, and the programmability is not that P4 algorithm we talked about. The network control is not that much implemented in the network, in the real life, I would say. Okay, so there are some implementation I know of that happened over the universities. I think ISC, IIT Bombay, then somewhere outside India, I think Purdue University, then some other universities are also having this ASEAN infrastructure for their campus network, but it is not getting used for extensively for the edge, to be precise, because whenever you are talking about the Airtel and Theo, so ASEAN has to be used for the edge, so it is not there yet. So now next question is, AI is applicable to improve the performance of the SDN by minimizing the latency, bandwidth, reallocation, and take care of the network if from currently deploys on SDN. Yeah, so there are two concepts that you can look into. So one is AI for SDN. So the first part of your question, that if AI is applicable to improve the performance of the network, yeah, it is possible. So if you have the network logs, you can use some AI algorithms, or different. There are different AI algorithms that you can use, and you can identify how you can improve the network performance, as well as if you have log of the network failures, and you can uh, train your network in a such a way so that before the it can be reactive, that means it can be proactive, that means before the network failure happens, that you can use the AI techniques to ensure that it is capable of identifying that, and that's how you can improve the network performance. But also you can use the SDN in other ways as well. That means you can use the SDN to enable the AI techniques. So as I was talking about, that AI can be on the both the sides and SDN can be in between. So it's kind of AI for SDN for AI. Okay. So now you can take any two combinations in between three and you can work on them. So it depends on ACL layers who would prefer to work with. So if you are using AI techniques for the network, then you are mostly working on the application. You are mostly working on the northbound API. That means either on the application layer or the control layer. Okay, basically, if you are using AI, so that would come as an application to your controller. Okay, and you will run your AI algorithm on the application layer, and whatever the outcome that is there, you will instruct the controller accordingly so that you have a better network performance. Yeah, so mostly I've answered this question. Yeah, so now if you have any question, please go ahead.
Yeah. So, anyone of you have any other question? Okay. I think
Uh,
there are no more. Yeah. Yeah. Go ahead.
yeah, so if you have any questions, just I'll share my slides maybe once. So you can yeah, so send me an email to this email ID. Oh, you'll, of course, you will get a response. I won't say that you will get a response immediately, but you will definitely get a response. And you
So,
can also visit my website and the website of the group to know more about how I work. Yeah, sorry, over to you, Kantan.
thank you. So I'll just share your email ID with the participants as well.
Yeah, sure. Please do that.
Okay, so thank you very much, all of you, for joining this talk, and special thanks to you, Dr. Ayan Mondal, for giving this wonderful lecture. I hope like it has been a very educative and informative talk by you where we learned about Edge AI and SDN and their integration. And I hope all of you, like in the audience, also feel the same. So on behalf of all of us here at CSSBC IEEE Kharagpur, as well as all the audience, I would like to thank you once again, Dr. Mondal, for taking out your valuable time and presenting this lecture today, being a Saturday weekend evening. So before we actually end the session, there is something that I want to present to you. I'm sharing it my screen. Is it visible?
Yeah, thank
Yeah.
you. Thank
So
you for the. Yeah.
from the IEEE CSSBC side, I would like to present to you this virtual e-memento as a token of recognition to you for presenting this talk,
Thank
a
you.
wonderful talk. And we hope that we can get to collaborate again soon enough, and regarding
Yeah,
the
please.
issues and all.
Please feel free to include me in whatever work you are doing,
Yes.
and yeah, so reach out to me.
Mm.
And before you end, and sorry again for being late because I was uh, like caught up with some other
Yeah, yeah,
events. Sorry.
that's not an
Yeah,
issue. And the audience over
yeah.
here,
Thank you.
participants also have been very much patient, and they have been,
Yeah,
like
thank you.
supportive.
Thank you for your patience. Yeah.
So thanks to the participants as well. Okay, so finally, before we end, as the last activity before we end, we would like to take a group screenshot. So I would like to request all of you who are present here, please, if possible, turn on your webcam or cameras so that we can take a group photo. We'll just wait for a couple of minutes in order to everyone for switch on the cameras. So yeah, I can see many faces. So yeah, I would like to request Ruelia, our vice chair, to please take the screenshot and confirm when it is done. Okay, we'll just wait for some time. It's okay. So thank you so much. It's done. So you can now turn off your camera. Once again, before finally, I would like to thank all of you once again. Oh, by the way, I forgot to mention. I hope all of you have noted your attendance in the attendance form. If there is someone who has still not noted down their attendance, I am pasting the link once again in the chat box. Please note down your attendance in this Google form. Okay, right. So this brings the end to this wonderful session. Thank you, Dr. Mondal, for taking out the time and presenting
Thank
the
you.
talk, and thanks to all the participants. We hope that we will be soon meeting, for some future collaborations as well. Thank you. Bye
Yeah.
bye. Good
Thank
night.
you. Thank you for the invitation and thank you. Thank you for.
Thank you.
Thank
My
you. Yeah.
pleasure.
Right. Bye.
Bye. Bye. All of you.
Yeah. Have a nice evening. Yeah.